This is the second part of our trig substitution worksheet. So the second set of values we're going to be, or the second set of problems we're going to be dealing with the secant substitution. So we're going to substitute over something that looks like this. Alright, so jumping down here again, notice that when we use the secant, it's the variable squared minus some constant. Okay, so we're going to look here at this example. Excuse me. So we have a variable squared minus some constant. So this falls into the way we when we do a secant substitution. So we're going to let x equal a, which is the square root of the constant part. So 2 times the secant theta. Alright, now what does that mean? Well, that means that dx is equal to 2 secant theta tangent theta. Alright. Also, it means, if we isolate the secant, it means that secant theta is equal to, divide both sides by 2, and we get secant theta equals x over 2. So if I make my right triangle here, here's theta, there's my right angle. Secant is hypotenuse, so there's the hypotenuse, over the adjacent side, so there's 2. Alright, so that leaves the opposite side to be the square root of x squared minus 4, using the Pythagorean theorem. Alright, and then there is everything that shows up in this integration. So the square root of x squared minus 4 over x is this over this, which according to this setup is opposite over hypotenuse. So that's the sine. So the sine theta is equal to what we have in our integrand, x squared minus 4 over x. Alright, so this, the sine, is equal to this, which is this. Okay. And then this dx is 2 secant theta tangent theta d theta. Alright, now we're going to just kind of clean this up. Now notice I've got a sign here, so I'm going to keep it. I'm going to pull this 2 out in front, so there's the 2. Secant theta is the same thing as 1 over the cosine theta. Alright, and then tangent theta is sine over cosine. Alright, secant is 1 over cosine, sine is obviously sine, but this tangent is sine over cosine. Okay, well, that's what we have right here. Sine over cosine is the tangent. So this means this is 2, I think, times the integral of tangent squared theta d theta. And then that integral, I've got the 2 here, integral of tangent squared theta is tangent theta minus theta. So 2 times the tangent theta minus theta plus c, alright, which is 2 tangent theta minus 2 theta plus c. Now, we need to know what the tangent theta is, and we also need to know what theta is. So, tangent theta we can get from here. Tangent theta is opposite over hypotenuse, sorry, opposite over adjacent. So that's going to be, looking at this up here, this divided by this. So that's 2 square root of x squared minus 4 over 2. Alright, those 2's will end up canceling. And then minus 2 times theta. Well, what is theta? The secant of theta is x over 2. So theta is equal to the arc secant of x over 2. Alright, so 2 times the arc secant of x over 2 plus c. Okay, and then clean this up. You got your 2's that'll cancel. So we end up with square root of x squared minus 4 minus 2 arc secant x over 2, and then your constant. Alright, next one, we got another one here with the variable squared minus some constant. So notice with this one, the 25 here is in front of the x squared. Now, we haven't seen one like that. So one of the things that we can do is pull out that 25 and say, alright, this is 25 times x squared minus 121 over 25. Alright, and then because 25 is a perfect square, what's 5 times x squared minus 121 over 25. Alright, and now this is still a perfect square. Alright, it's 11/5 squared. Okay, but that 5, we can pull it out if we have something in front of the x squared. Alright, I'm going to go ahead and pull it all the way out of the integration completely, so I have something that looks like this. Alright, so in this case, I'm going to let x equal, again, this is secant because it's a variable squared minus the constant. So I'm going to let x equal 11/5 secant theta. Okay, so what does that mean dx is? Dx is 11/5 secant tangent. Alright, it also means that if I divide both sides by 5/11, or 11/5, meaning multiply both sides by 5/11, I get 5x over 11 is equal to the secant theta. Alright, so if there's my theta, right, secant is hypotenuse over adjacent, so 5x over 11. That means that this over here is 25x squared minus 121. Alright, now what do I have over here? I have that 25x squared 121. I have that in the denominator. Okay, now if I could come up with something that has a constant up top and then this in the denominator, I can make a direct substitution here. Alright, so what I'm going to do here is, again, I can't use the x. I don't want to bring a variable into this. I can bring a constant but not a variable. So I'm going to use the 11, alright, and the square root of 25x squared minus 121. Right, that needs to be in the denominator, so I need some function of theta to be equal to 11 over square root of 25x squared minus 121. And which trig function of theta is that? That's adjacent over opposite, so that's the cotangent. Alright, so cotangent theta equals this, so 1/11 of the cotangent will equal this. Alright, what we have. Alright, so this, dx is this. Alright, and then I'm going to stick a 1 in there just because we have one right here. So that 1 and this is equal to cotangent theta over 11. Alright, so I'm going to make my substitution. I'm going to pull the 11 out, 1/11. 1 over 11 times the cotangent, that's in the green, cotangent theta. And then the yellow is dx, that's 11/5 times the secant tangent. Alright, now first thing that's going to happen is cotangent and tangent wipe each other out. Alright, this 11 and this 11 wipe each other out. And this thing cleans up rather nicely to 1 over 5. Alright, pulling this 5 out front. The integral, 1/5 the integral of, the only thing left here is the secant. Don't forget your d theta. So 1/5 the integral of the secant theta, d theta. Alright, now I gotta have a 5th out front from the 1/5 that shows up, and then the integral of the secant is the natural log of the secant plus the tangent. Okay, so the derivative of the secant is secant times the tangent, but the integral of the secant is the log of the secant plus the tangent. Alright, now secant theta, we know that's equal to, right here. There's the secant. Alright, and then the tangent is opposite over hypotenuse, so the tangent is the reciprocal of this. So the tangent theta equals 25x squared minus 121 over 11. So when I come back and plug everything in here, I've got 1/5 natural log of absolute value. Secant is 5x over 11 plus the tangent is 25x squared minus 121 over 11 plus c. Alright, and then now we're just going to do a little bit of cleanup here. So 1/5 natural log, because we can combine these two numerators because they have a like denominator, we get 5x plus the square root of 25x squared minus 121 all over 11. Alright, and then a property of limits plus c. And then a property of limits says, I mean not limits, but natural log says if I have a log of a quotient like this, I can take the log of the top and subtract the log of the bottom. But because the log of the bottom is just a constant, it's going to get gobbled up by that plus c. So we just simplify it down to this. Alright, number 6 again, we got a secant that we're going to make a substitution over. So this time we're going to let x equal 2. And our variable here is 2 because there's nothing in front of the x. So 2 times the secant of theta. Alright, that's going to make dx equal to 2 secant theta tangent theta. Alright, and then it's going to make the secant theta equal to x over 2. So let's make our right triangle. Alright, secant is hypotenuse over adjacent, so x over 2. That makes this equal to square root of x squared minus 4. Okay, Pythagorean theorem, this squared plus this squared equals this squared. That means that this squared minus this squared equals this squared. So we take the square root of x squared minus 4 to get that opposite side. Alright, now looking at what I have, noticing also that this, okay, remember that's the same thing as the square root of x minus 4, or x squared minus 4 cubed, right? That's the same thing as that. Okay, so keeping that in mind, we can come up with something that looks like this. Okay, so keeping in mind a couple of things. One, this is in the denominator. This radical thing right here is in the denominator. We need a whole number in the numerator, so that's going to be the 2 here. So we want another function that has 2 in the numerator, the square root of x squared minus 4 in the denominator. Alright, so 2 is, again, I'm putting this down on the bottom because it's on the bottom in this fraction. So that's going to be, again, the cotangent. Alright, and if I divide both sides by 2, or multiply by half, alright, we get something like what we have here, a 1 up top. And if I take both sides of this, and all of this, and all that's remaining here, and I cube it, alright, I get 1/8 the cotangent cubed theta equals, now we just have a 1 up top, 1 over all of this cubed is x squared minus 4 to the 3 halves. Alright, so that means that, let me erase because I've got a couple different highlighter marks on there. That means that all of this in the denominator now, including that 1, is equal to 1/8 cotangent cubed. Okay, and then our dx, 2 secant theta tangent theta. Alright, so let's substitute dx 2 secant theta tangent theta alright, all that in yellow, 1 over, actually let me erase that because it's not, all this in yellow is 1/8 the cotangent cube, so I'm going to put 2 over 8. Alright, cotangent cubed alright, now tangent will get rid of one of these cotangents. Alright, now 2/8 reduces to a 1/4. Alright, and then I'm left with a secant theta and a cotangent squared theta. Now I'm going to write that as 1 over the cosine of theta. That's what secant is equal to. Alright, the tangent theta is gone. Cotangent squared theta is cosine squared theta over sine squared theta. Alright, so this cosine will cancel with one of those cosines. Alright, and I'm left with 1/4 the integral of, there's a cosine theta over a sine squared theta d theta. Now it's time to do like a U-substitution. So if I say that U is equal to the sine theta, that means du is equal to cosine theta d theta. Alright, so doing this substitution, I've got, there's sine, so that's u squared. On the bottom, sine is u, so u squared, and then cosine theta d theta is du. Alright, and then the antiderivative of 1 over u squared is, if you think of this as u to the negative 2, the antiderivative is going to be add 1, negative 1 divided by 1. So u to the negative 1 over negative 1 plus c, which is 1/4, negative 1/4 times 1 over u plus c. Now, do your substitution back. U is the sine theta. I came down to this side, so here's what we are standing at now. U is the sine theta, so technically this is negative 1/4 times 1 over sine theta plus c, but what is 1 over the sine theta? 1 over the sine theta is the same as cosecant theta. Alright, and then the cosecant is defined to be, according to this, what we had on the first. Cosecant is hypotenuse over opposite. So that means this would be negative x. Alright, substituting cosecant in right here, so I get a negative x over 4 times that denominator, 4 times the square root of x squared minus 4 plus c. Alright, so there is our antiderivative back in terms of c. In terms of x.